Okay, review for the last tests. Okay, this is a study guide for test 4. This is what I mentioned last week. But anyway, history, science, there I want you to think about a 1 or 2 word description of each of the major scientists, what they discovered up until the quantum mechanical model. Electron, protons, neutrons, we're going to fill out a table looking at different isotopes with different electrons and protons. We're going to look at electronic configuration, temperature, Kelvin versus Celsius, and the gas laws, both the ideal gas law and changes in conditions for gases. So let's talk about the history of science is very straightforward. It's just a matter of thinking about well, give me a second. We were going to start at Democritus. He's known for coming up with the concept of an atom. Talk a little about alchemy, problems with alchemy. Don't worry about this. Dalton was the first European scientist to come up with a atomic theory. He's considered a very big landmark in science. And these are, so the one word for Dalton would be first atomic theory, European scientists. Thomson, credit with plum pudding and discovery of electrons. Millikan, the charge of electron. Rutherford, discovering the nucleus. Chadwick, talking about he discovered neutrons. Ashton discovered isotopes. Bohr came up with a planetary model of the atom. Electrons filled from the inner outward in 2, 8, 8, 8, 18, etc. And then there's the quantum model, which we get into the electronic configuration of the electrons. So let's talk about that. Okay, all right, so via the quantum mechanical model of the atom, each electron has got a unique configuration. It comes in 4 parts. There's the shell, subshell, orbitals, and spin. So if we look at boron, for example, boron has 5 electrons. And those 5 electrons, we're going to start here, and we're going to go to boron, and we're going to pass through the S block, B block, the D block, and the F block. Now, getting to boron from hydrogen, we're not going to be going through very many blocks of electrons. So we're looking at starting at shell number 1, 1s2, 2s2, and 2p1. So we've got 2, 4, 5 electrons, all accounted for. If we look at the orbital representation of that, so that's the p electron orbitals, the s, and the s. And this would be the shell 1, shell 2. So there's 2 electrons in the 1s, 2 electrons in the 2s, and 1 electron in the p. We look at let's look at gallium. Okay, to get to gallium now, we're going to be going through the 4s series, and then we're going to drop down to 3d, and then back up to the 4p. That would be for gallium. Okay, so I've got worksheets on this, all this stuff to practice. But you need to be able to, one, understand the correct setup in terms of the lower orbitals fill first with the maximum number of electrons because they're the most stable. So these are all maxed out on these blocks. Okay, so let's go ahead and go on. Let's look at electrons, protons, and neutrons. You're going to get a table very similar to this on your test. And you're going to have to fill it out. Okay, so atomic number 17 is chlorine. So the symbol is going to be Cl, and it's 19. That's protons and neutrons, and it's got 17 protons. So these two are always equal. 19 is atomic mass, which is P plus N. So P is not 17, so to get to 19, we have to add 2 neutrons. And because these are neutral, the protons and electrons are going to be equal. Let's look at this one here. We have atomic number 56. It's neutral, so that means there are 56 electrons. We have the symbol is going to be, if we look at 56 in terms of atomic, we need a periodic table here. Okay, so element 56 is what? Cesium. And that's a 56. And Atomic mass is going to be P plus N, so that's 136. Name is cesium. Cesium 136. Okay, then you'll get an ion version of the same table. And I've got practice of these again on files. Okay, we're looking at nitrogen. Nitrogen is atomic number 7. Protons, atomic number are the same. Neutrons, okay, we've got 18 for the atomic mass. That means there are 11 neutrons because 7 plus 11 is 18. And we have a -2 charge. That means there are 2 extra electrons over protons. That means there are 9 electrons. And this would be nitrogen 18. Okay, 13 protons. 13 protons is going to be aluminum. And we need atomic mass is going to be P plus N, so that's 20. Okay, so let's go through, and here's some generic questions about number of particles, ions, isotopes, etc. So how is an ion different from a neutral element? Protons do not equal electrons for an ion. In neutral element, they're equal. Positive cations, anions. Okay, what is an isotope? Isotope differs in the number of neutrons. The atomic number of oxygen 18. So atomic number and number of protons is the same thing. Look over here to oxygen. So that's 8. Okay, what's the difference between oxygen and oxygen -2? -2 is 2 extra electrons. Why do isotopes have different masses? So carbon 12 has got 6 protons, 6 neutrons. Carbon 14 has got 6 protons, 8 neutrons. Okay, so an element or ion has 8 neutrons, 8 electrons, 8 protons. So if we look over here and find atomic number 8, that's oxygen. If an element has 8 neutrons, 9 electrons, and 8 protons, what is its charge? Okay, so there are one extra electron over proton, so the charge is going to be -1. How can an element have two atomic masses? That's isotope. So we can give an example of carbon 12, carbon 14. Okay, who is Rutherford and what is he famous for? Discovered the nucleus. Okay, so those are typical questions I'd be asking regarding particles, the number of particles, isotopes versus ions versus neutral uh, atoms, etc. Okay, let's go on here. Let's talk about gases. Let's talk about temperature first. Frequently in chemistry and physics, we're talking about different thermodynamic properties. And whenever we do, we always talk in terms of absolute temperature. The absolute temperature is relative to the kinetic energy. And when the kinetic energy is 0, that means the absolute temperature is 0. The units of Kelvin are the same as Celsius. It's just the starting place is different. Okay, so with water, so we've got water freezes at 0, water boils at 100 Celsius. We need to add 273 degrees to go from Celsius to Kelvin. So 0 plus 273 is 273. 100 plus 273 is 373. So we always use the Kelvin scale whenever we're working with thermodynamics and whenever we're working with gas laws. Okay, so there are two types of problems we're going to be working with in terms of gas laws. We're going to be using the ideal gas law, which is this here. Okay, so there's pressure, liters, moles, temperature. And all we're doing is we're substituting into that equation. If I said, what's the volume of, well, like in this problem here, what's the temperature if we have a volume of 128, pressure of 2.08 atmospheres, moles, etc. You just plug it right into the PV is equal to MRT, and you would come up with two answers. You come up with Kelvin, and you come up with centigrade or Celsius. And the other type problem is a change in parameters. So we'd have initial parameters and final parameters. So you're looking at PV over NT. Initial is equal to PV over NT final. Now, whatever's the same on both sides, you get to cancel. So, for example, in this problem here, the volumes are the same. So we can then cancel the volumes. Also, if number of moles doesn't change, we can cancel moles. Now notice moles are not mentioned. If moles aren't mentioned, that means it doesn't change. What does change is the temperature. So we don't know the temperature, and the pressure goes from 128 to question mark. So initial temperature is 100, final temperature is 300, 100 plus 200. So all we're doing is plugging into this what's left over. We'll end up with 3.84 atmospheres. Now, in our class, pressure is in atmospheres, volume is in liters, N is moles, and temperature is Kelvin. N is equal to 0.0812. Now, when you get into 1A or 2A, you may be using pascals for pressure or millimeters of mercury, and then the R is going to change. So different R's depending on what units you're using. But for our class, we're using the simple atmosphere, liters, moles, and Kelvin. So you're going to get a problem on each one of these. Okay, so that's kind of the review. Those are the type problems to expect on this last test coming up. Okay, so what we're going to do now is stop sharing. And again, I want to remind everyone there are two tests, one on Saturday, the 17th, and one on the 23rd, Friday. It's going to be the same tests. You may take one or the other, not both. If you take both, I will take the lower of the two scores.